Okay, so we are going to cover this silo. So we define traffic stream as made up of vehicles, okay, and these vehicles are controlled by drivers, okay, and they interact with each other. Their movement depends upon the design of the road and the general environment, okay, and the traffic flow changes from time to time, place to place, direction, lanes, everything changes, okay, and these are the two main reasons, okay, changes in vehicle and changes in driver behavior. And then based on traffic flow, we can divide the highways into two types. We have uninterrupted and interrupted. The main difference between them is intersections, okay. So uninterrupted don't have intersections, the other one has. Then there are also two types of traffic data, macroscopic and microscopic. Macroscopic is the bigger level when you're looking at the whole traffic stream, okay, and microscopic is when you're looking at each vehicle or maybe a pair of vehicles, okay. For each case we have some parameters which we'll study, okay, and we started with the first one, which was macroscopic parameters, and we are looking at the first parameter, which is volume. Okay, the main term is volume, but you can see here there are three things mentioned here: volume, flow, and rate of flow or flow rate. Okay, why they are mentioned together? Because for all of them, the units are vehicles per time. Okay, for all of them, the units are vehicles per unit time. Okay, if the time is day or hour, it's called. If it is less than 1 hour, we call it flow. If you take the flow and convert it to 1 hour, we call it flow rate. Clear? Okay? Any questions? Now, going back to volume, we said volume can be per day or per hour. If it is per day, we call it daily volume. Okay? If the volume is taken per day, we call it daily volume. Now, what is the use of daily volume? It's used for planning and documentation. So, you want to prepare a document which shows you the traffic trends in Bahrain. Okay, and we will use daily volume. Okay, or you want to predict what will happen after 10 years with traffic. Even for prediction, we use daily volume. Okay, and daily volume is always total. Total meaning total of both directions. Okay, daily volume is taken as total of both directions. So it's used for documentation and it is taken as total of both directions. Clear? Okay. Now somebody says that I took a volume, let's say for today, 10 February, right? And he gives me a value. Okay, so he gives me a value of 10 February 2025. Can I take this value for my future planning and documentation and so on and so forth? Can I do everything on the basis of this one value? We cannot, right? Because tomorrow value will be different. Next week, Monday, volume will be different. After 6 months, it will be different. Okay? So if you are doing something on the basis of one value, it will not be accurate. Okay, so what do? We don't take 1 day of volume, we take average of daily volume. Okay, for more accurate working and prediction, we take an average of multiple days. The volume is taken for multiple days and then you take the average, and this average will be used for anything else. Okay, there. Okay, so average can be taken in 4 different ways. The average of daily volume can be taken in 4 different ways. Okay. The first one is you take the average for annual. Okay. So you take the average for the whole year. That means almost 365 or 366 days. Clear? Okay, and we call it average annual daily traffic, AADT. Okay, this is taking the average of the whole year. Another method of taking the average is, yes, you take the average of the whole year, but only for weekdays. So weekends are taken out. Okay, weekends are not considered. Clear? Okay, and we call it average annual weekday traffic, AAWT. Okay, and since you took the weekends out, so the number of days are less. Okay, they are around 260, but the actual value changes, right? The actual value you have to count. Clear? Okay. So how many days we are counting then every day, every week? Sorry. Every week, how many days? 5, right? Around 5. You may also take out national holidays. Okay. In our case, like Eid and National Day and so on, they can be also taken out. Same reason. Okay. Then we have the other method of taking the average, where you are taking average of daily traffic, but there is no annual here. Okay, it's still an average of daily, but not annual. Okay, so this is less than 1 year. Okay, it's always less. When you see it without annual, it cannot mean 2 years or 3 years. It means less than 1 year. Got it? Okay. So we call it ADT, average daily traffic. Okay. And the last one is you are taking the average of what? Weekdays. Do you see annual here? No. So it's what now?
Less than 1 year.
Less than 1 year. Only weekdays and less than 1 year. Clear? Okay. So 4 different methods. Take the whole year, all days. Take the whole year, only weekdays. Take less than 1 year, all days. Take less than 1 year, only weekdays. Clear? These are the values which you can use for your documentation prediction. A very small example, simple. We have data taken for all months of 1 year. Okay, so the month, the number of weekdays in every month. Like I said, you have to count it. To open the calendar and you have to see how many days, weekdays. Okay, and what about this? Do we need to count?
Total days a month.
Yeah. Do we need to count? No, right? How do we know?
From the calendar.
From the calendar. We don't give you the calendar in the exam then.
Should we memorize that?
Very good.
It's 31, 30, 31, 30.
Very good.
Except February.
31, 28.
Except February, I said.
After February, okay. And 31, 31.
Wow.
This has happened, that's why I'm asking. In one exam it has happened. They were asking me how many days. I said, okay, fine, whatever you remember. They put 30, 30, 30, 30, 30. February was also 30. Okay? Yes? We are about to sleep, that's why I'm asking you. How do we know which month is 30, which month is 31? How do we know? This is not allowed in the exam.
January is 31 and then it's like 31.
Then God knows, right?
Yes.
Allahu Alam. Right? Yes, you were saying something.
No, nothing.
Nothing?
I was saying Allah Alam too.
Okay.
Just
Yes.
because it's 5 days. 31, 30, 31, 30.
It will not make 365.
Like,
That's the
excuse
fun.
us. We must excuse us.
Why?
Can't use phone.
Why?
Can't use the calendar.
No.
Yeah.
Okay. Find out. There's a method. Okay. Without the calendar, without the phone. Okay. Anyways. But they are fixed, right? Everybody agrees they are fixed. So this one you have to count. You have to know for every year it can be a different value. This one it's the same. Right? Okay. So this is the total of the whole month. So this value is in this. This value is for this number of days. Got it? And this is the total of the weekday. Okay? So this value is for column number 2. Weekends are taken out. Clear? Okay. Now they are saying first of all calculate ADT. What do we mean by ADT? What was ADT? Average annual, right? So that means the whole year. I have to take the whole year. Okay, the traffic of the whole year and the number of days of the whole year. The traffic of the whole year, total of every month, and the total of all the totals, right? Okay, so this one. How much?
One
We
four
should-
917.
1491.
7.8.
Okay.
7.8.
What will I do with 0.2 liters?
You round it up.
Okay. Any problem in this one? Total, right? Okay. The next one is AAWT. Okay. Which means what? Weekday, right? So I have to take the whole year or only the weekdays. Okay. So now I take the last column. Okay. This is the total of only the weekdays. So I will take the total of these totals. Okay. Which is and the total number of weekdays are also given here. How much is that? 9,935. Okay, any problem up till here? Okay. Now they are also asking for ADT. Okay. ADT means what? Average what? Daily. Okay. Is it 1 year or less? Less. How much less? Huh?
Less than 1 year. So that's
Less than 1 year. But how much? How much in this case? Okay.
1 month.
1 month. Okay. But it's not fixed. It's not fixed. If the data is given for every week, then ADT will be for 1 week. Okay. So it is not fixed. But here it is 1 month. So I will take it for 1 month. Okay. And 1 month total or weekdays? Total. Okay. So I am taking it for January, for example. So it will be this. How much?
One 3709.
Okay. And what will be the difference for AWT? If I want AWT, then
Average for the weekdays.
weekdays. Okay. So I will now take the value from the last column. Okay. How much is this?
9454.
Okay. They are asking for these 4 values. Okay. Is this question complete? Did I finish the answer? No? What's left?
For each month.
For each month. Because they gave me 12 months, right? They gave me 12 months, data of 12 months. I only did it for the first month. Which values I will repeat for each month? Which values I will recalculate for each month? There are 4 values, right?
Yes.
Which of them for each month?
So the total.
Yes,
First one.
ADT.
Yes.
The ADT and
The last 2 values. You have data of 1 year. So you cannot calculate two annual values, right? This is done. These two are done. They cannot change for each month. They are annual. Okay. So for each month you will calculate these two values. Got it? Clear? Okay. Any questions? Okay. One thing here, normally when you are doing the exam, you write your answers. So normally I don't deduct the marks for the units. Okay, you write it, you don't write it wrong, something like this. Okay, what did you say? Excuse you. Okay, but keep in mind what you are calculating. If your units are wrong, most probably your value is also wrong. Okay, so you calculate a value which is in miles per hour, but I'm asking for volume. Okay, so it's not a mistake with writing miles per hour. The mistake is what you calculated as miles per hour. Miles per hour is what? Speed. So that means you calculated speed. So your answer is wrong because I was asking for volume and you gave me speed. So that's why your answer is wrong. Okay, so if you get a 0, it's not because you wrote miles per hour. It's because you calculated miles per hour. Okay, so keep the units in mind. Make the habit of writing them. Okay, and pay attention to them. Okay, so you will avoid the major mistakes. Okay, in this case it helps you, not here, not today's lecture, maybe, but in other lectures you will see if you are matching the units. From the units you know what to do with the values. I want to calculate miles per hour, what divide by what, or what multiply by what. It's that simple. Okay, so what's left here is the ADT and AWT for each month. Okay, so you can finish it later on. Then we have hourly volume, because we said volume can be per day or per hour. Per day we already discussed. Now we are on the hourly volume, per hour volume. Okay, we use daily volume for what? What was the purpose of having daily volume? Yes. Why do we need daily volume?
For data.
Huh?
That data.
Hourly volume is also data, right? What is the specific purpose of having daily volume?
For future.
Yes. Okay. Documentation, future prediction, and so on. Okay. Hourly volume is used for design. Hourly volume is used for design and traffic management. So if you are designing a highway, designing a signal, designing a roundabout, you will use hourly volume, not daily volume. Okay. You want to change the signal timing. You want to change the speed limit. So you are managing traffic, right? It also requires hourly volume. Okay. So hourly volume is for traffic management and design. Clear? Another difference between daily and hourly is, I told you daily is total of both directions. Hourly is per direction. Okay, daily is a total of both directions and hourly is taken for each direction separate. Okay, clear? Now let's say you are doing some design. Okay, design will be for present or future? Future, right? The design should work for many years. Okay, so somebody should give you a future value, right? Okay, but future volume is what? Daily or hourly? Daily. So they tell you, okay, we need a new highway, this is a volume. Which value they will give you? Daily. Okay, now you have to convert it to hourly. So for design, then you need the hourly volume. How do we convert it? This is the equation. Okay, this is the volume you want and this is the volume you have. Volume you want, directional design hourly volume, DDHV. Okay, directional because I told you it is for each direction separate, right? Okay, design because I am using it for design and it's hourly volume. Clear? Okay, then we have A. A is average daily traffic, average of daily traffic. Okay, but we said there are how many methods of doing the average? 4, right? It can be any of those 4 values. This A can be any of these 4 values. It depends upon data you have. So somebody only gave you 1 month of data, and you cannot do AADT and AAWT, right? This is annual. Somebody only gave you weekdays data, I cannot do. Okay, the total. Clear? Okay. Now if you look at, and it can also depend upon the function of the highway, the type of highway you have. Okay, now you look at this data. So we have the average for the total and we have the average for the weekdays, right? Which one is higher, total or the weekday? Total is higher, right? Even for January. So this is for the whole year, right? So for the whole year, total is higher, weekday is lower. And if I just take January, same thing, right? Total is higher, weekday is lower. What does it mean? When do we have high traffic?
Daily.
Huh? Daily?
Total.
Total will have more. But what is happening within the days?
More day?
Yes, we have 10 days of the week. Huh? Which type of days have more traffic?
Weekdays.
Weekdays? Weekdays lower, right? Weekends have more. So when you took the weekends out, it became less. So that means weekends have more traffic. Okay? But if you do it for this highway as a Lec road, for example, you will see the reverse, right? When you take the weekends, because the weekday traffic is higher, right? So the average will go up. Okay? So it also depends upon the type of highway. Where is it? Got it? Okay? It's not because of number of days. Because when you take the traffic from the top, then you are also reducing the number of days as well, right? This is what you are seeing, I believe. Right? Yeah. You are taking traffic of less number of days and you are dividing by less number of days. So it has nothing to do with number of days. Okay? It has to do with which days have more traffic. In this case, weekends have more traffic. So when you take the weekends out, the traffic becomes lower. But if you do it for an urban area, a marketplace or something, you will see the reverse. Okay? So which value, coming back to the discussion, which value should I put as A here depends upon what data I have and what type of highway is it. Okay? If I have data of 1 month, obviously I will use the data of 1 month. I don't have any other option. But if I have options, like in the previous example, I have options, right? Everything is given. Then I can decide on the basis of the type of highway here. Clear? Okay. So A can be any type of average of the daily. Any type of average. Clear? Then we have D and K. Now this is for both directions, remember? The daily is for both directions. Okay, I have to separate the two directions. So D is the percentage of traffic in the peak direction. Okay, D is the percentage of traffic in the peak direction. Both directions cannot have the same, right? Or not, they will not always have the same. Let us put it this way. Okay, if it was same, I will take the total divided by 2, right? Always. But I cannot do it. In many cases, one direction has more, the other direction has less. Okay, so D is the percentage in the direction which has more. Okay, the direction which has more. Clear? So one has 60%, the other one has 40%. D will be what? 60 or 40? 60. Right? Okay. Then A was the daily, so it has all the hours, right? And I want to convert it to 1 hour. So K is the percentage of traffic in the peak hour. Okay. Clear? Okay. So I have the average of the daily, which was for both directions, multiplied by the percentage in the peak direction, multiplied by the percentage in the peak hour. Clear? Clear? Okay. K and D, there are no equations. You have to observe them. You go to the highway, you take the data, and you see what percentage of traffic I have in each direction, what percentage of traffic I have in the peak hour. Okay. So it can be different for different types of highway, for different areas, and so on and so forth. But these are observation based. You have to observe them and calculate them. Okay. Calculation percentage. Okay. Find out the percentage. Okay. For doing the examples in the book, they have given us this table. Okay. okay, which also gives you some idea about how these values change. Okay, so they have given the ranges for different types of areas: rural, suburban, and urban. Okay, which area has more population? Urban, right? Okay, and the rural has very low population, villages. Okay, basically. Suburban is an area which is on the boundary of the urban. It's a very popular term. Okay, so any area which is on the boundary of the urban area, they call it suburban. Clear? Okay, so areas with low population, boundary of the urban area, and the urban area which has very high population. Clear? Okay, now for the first two cases I have only one row of data, right? For the last case I have two. Okay, the first one is radial, the other one is circumferential. Okay, radial means what? Radial comes from radius. Okay, what is the radius? Half of the diameter. It goes from where to where?
From the center.
From the center to the boundary, the edge. Okay, so radial means the same. Radial here means the same thing. A road or route which goes from the center to the boundary. Clear? Okay, and circumferential comes from circumference. So circumference is, how do you draw the circumference? How do you draw the circumference?
Circle.
Circle
itself.
Around?
The boundary.
No, around what? Around the, if I ask you to draw a circle, you will mark what?
The center.
It's the center. Okay, so we road around the center. Circumferential means the road around the center. Clear? Okay. Now you see, look at the values and you tell me when you go from rural to urban, what is happening with the values? Increasing or decreasing? Huh? Decreasing, right? And what about the population? Increasing or decreasing? Increasing. Population is increasing, the values are decreasing. Population more means traffic is? Okay. When traffic becomes high, when total traffic is high, people try to balance. Okay. Because they know if they go at this hour, they will get stuck. Okay. So as much as possible, they try to balance. They go to a different direction, different highways, different times, right? Okay. So the percentage becomes less. Okay. So for example, if I have 30 chairs, okay, and I have exactly 30 students, okay, so it's what? Even, right? Equal distribution. So you see here, 50% means what? Equal, right? Okay, because the traffic is high. Okay, so when traffic is high, people distribute automatically in different directions. So the traffic becomes almost even. Okay, it is distributed. Okay, but right now, if you see, what is happening here? We look at the class. Very high here, and very low here. Right? We should invite more girls. Okay. So you see, now why is this uneven? If all the seats were filled, it will not be like this, right? They are almost equal and equal. Okay. So the total is high, then things become almost equal. Okay. I had a bottle here. Yeah. If I fill this bottle, the volume of water will be high, right? And at every point it will be equally distributed, right? The top and the bottom are equal, but now it is half filled. Okay, so now it's unequal, right? Okay, so when the total becomes higher on the same road, it will distribute. Okay, so that's why the percentage goes down, because now it's equally distributed. That percentage is less. Okay, when the total traffic is low, then people know they will not get stuck. So everybody comes on the road at the same time, no problem. Okay, so that's why the percentage is higher. Okay, let's consider this example. We have forecasted ADT, which is for the next 20 years. After 20 years, they are expecting traffic to be this much. Okay, now what was ADT?
Average daily.
Okay, so it's for the whole year, right? and this is the value, and they are saying using the factors in that table, find out the range for the ADT. Sorry, DDHV, directional design hourly volume. So we have the ADT, okay, and the road is for a rural area. Okay, so I will use the factors for the rural area. Now you can see the factors have a range, right? It's not one value, it's not a single value. Okay, so I will use both values here. Okay, how much is each value?
6,000.
This is what? First one, second one?
No, the second one.
Second one. Yeah, and the first one?
2925.
Are these values close to each other? No? They're not even close, right? Okay. So you have to be careful in selecting the factors. And that's why I said there are no equations. This is just for the sake of doing the examples in the book. Okay. Even the people who did this, who collected this data, cannot use any value. Get my point? Okay. Let's say this data was taken maybe 20 years ago in US. So even people at that time in that place cannot just pick any value. They have to be careful. Okay. So if somebody is always taking the lower value, his road may fail most of the times. Okay, because he is ignoring so much. Okay, and somebody who is taking the higher value always, he may be over designing most of the times. So he is ignoring the cost. So he may be spending millions, okay, higher than what is required in most of the cases. Okay, so you have to be careful in selecting the value. Okay. Then one thing which we did yesterday was flow, okay, which is also called as sub-hourly volume. So flow and sub-hourly volume means the same thing. Okay. Yes.
I have a question. So which value should we select in between then?
You can, but you have to rely on the actual data. That's what I'm saying. These values just provide you some guidance. Okay. If you don't have anything, we can work with that. Okay. We have flow, which is also called here as sub-hourly volume. Okay, and I explained to you yesterday, flow is what? For 1 hour or less than 1 hour? Less than 1 hour. Okay. So for planning, for future protection, we need daily. For design, we use hourly. Okay. Then why we are bothered about the flow? Because in 1 hour, traffic does not come at equal intervals. So for example, in 1 hour, I have 3,600 vehicles. 1 hour, 3,600 vehicles. Okay, that means 1 vehicle per second. 3,600 vehicles means 1 vehicle per second. Okay, but is it possible that vehicles keep on coming after every second? No, right? It doesn't happen like this. Okay, maybe the first 15 minutes there were 1,000 vehicles. Next 15 minutes there were 1,500 vehicles. Okay, and the last half an hour it was, I don't know how much it was maybe 1,600 something. Okay, so traffic can go very high and very low even in the hour. Got it? even in the hour, the traffic goes high and low. From minute to minute, 15 minutes to 15 minutes, it can change. Okay. If you do not consider this variation, your design can fail. If you do not consider how traffic is changing in terms of flow, then your design can fail. Okay. How is that? Let us look at an example. So we have taken, we have traffic taken from 5 to 6 p.m. 1 hour, right? 1 hour. The total is how much? 4,200. What do I call this value? This from 5 to 6. What is this? Flow, volume, or rate of flow?
Volume.
It's volume, okay? It's volume, it's hourly volume, it's for the whole hour, okay? Then, they did not just take the total. They counted traffic for each 15 minutes. The total is coming from these 15 minutes values, okay? So what is each of these values? Flow. Each value is for 15 minutes, right? So we call it flow. Then they take each value and they convert it to 1 hour. Okay, so we call it flow rate. Data. Got it? So this table has all the 3 terms with the calculation and everything. Clear? Okay, total of 1 hour, volume. Each 15 minutes, flow. Flow converted to 1 hour, flow rate. Okay? So you can see the variation over here. 1000, higher, higher, and then suddenly very low. You can see the variation, right? Somebody comes and says, okay, let the variation be, I will just take my hourly volume. My equation says put hourly volume in the equation. Like you guys. The equation says I will put A, this is A, whatever it is. So you put it. Okay, so you put this in the equation, or you are only taking this value. Okay, 4,200. Okay, 4,200 in 1 hour, right? 4,200 in 1 hour. How many in 15 minutes then? According to this value. 4,200 in 1 hour, that means 60. 1 hour is 60 minutes, right? So how many in 15 minutes?
1050.
1050. So if your design volume is 4,200, if your design capacity is 4,200, then in 15 minutes your capacity is clear? Okay or not? Any problem? Clear? Sure. Okay. Now if you look here, what will happen? In the first 15 minutes, now what do we want to be more, our capacity or the actual? Capacity should be more, right? Actual should be less. In the first 15 minutes, same case. Okay? Capacity is more, actual is less. No problem. Okay? Next 15 minutes, what happens? Capacity is less, actual is more. Okay? If this happened on a building, you may start to see the cracks and so on. And this is a road. It doesn't crack. Okay? But it will, what will happen here?
Cause more traffic.
Huh?
Cause more traffic.
Cause more traffic. Well, what will happen to these vehicles? What will happen on the road?
Accidents.
Accidents?
They can enter.
They cannot enter.
Crowded.
Yeah, so the
Huh?
biggest road.
Crowded.
Everybody in the road.
Okay. Now, what happened? 1050 vehicles can pass in 15 minutes. Out of 1100, these much will pass. How much is remaining? 50. These 50 vehicles need more time now, right? So after this 15 minutes is finished, I have 15 vehicles waiting which need more time to pass. Clear? Okay. So I have 50 vehicles waiting now. I have 50 vehicles waiting at 5:30. Okay. Next 15 minutes, what will happen? I have actual, again more, and the capacity is less. So again, out of the actual, the capacity will pass. Okay, and the remaining still are now stuck. Okay, they still need more time. Okay, so how much is more here? 150. What happened to these 50 vehicles who were already waiting? Did they get the chance to move? Did they get? No. Huh? They didn't. Okay. They had more flow coming, right? Okay. Saying yes in every case. Okay. So total is 200 now. Okay. Those 50 which were remaining from these 15 minutes, and then 150 which were added. None of them got a chance or the extra time to move or the extra space to move. Okay. Last 15 minutes. What happened now? Actual is less, capacity is more. Okay. So these 900 will pass. These 900 don't have any problem. Okay. But now I got some extra space for the leftover as well. Okay. How much extra space I got now? How many extra vehicles I can? You subtract. Okay.
And then you have 50 remaining.
So I had 900, and out of the total 150 will pass, and how much is remaining? 50. Clear? Okay. So this was the vehicles which I already had. This one added. Out of the whole 1050 will pass, and the remaining is only 50 vehicles. Okay. And that means what? You designed for how much? 4,200. But you got how much? Out of 4,200, 50 did not pass, right?
4,150.
So you passed, you allowed 4,150 vehicles, not 4,200 vehicles. This happened because of what? Because of this 1,050, right? Your 15-minute capacity was 1,050. Okay. This 1,050 should have given you how much? 4,200. But it didn't. Why not? Because of the variation. If all 15 minutes had this much, would you have any problem? But did it happen? No. So now we have a problem that we did not reach the volume which we designed for. Okay, so this is why we need to consider the sub-hourly fluctuation, the fluctuation of or variation of traffic in the hour. Okay, how do we consider it in the design? We calculate a factor which is called as peak hour factor. Okay, so if you go to this example, you remember we calculated the or this one. We calculate this hourly volume, right? Huh? So somebody says I will take this value, 6,000. You cannot take it directly. You have to divide it by the peak hour factor. Okay. So your design value should be divided by the peak hour factor before you use it for design. If you don't, then the same thing will happen which I showed you in that example. You will have that problem. Okay, so peak hour factor accounts for the fluctuation which is happening in the hour.
Should be given, doctor?
No, no. Okay, so what do we do with the peak hour factor? There is no table for peak hour factor. Okay, for D and K there were table, right? There was a table. Okay, or you observe it. But peak hour factor has an equation. Okay, the equation is hourly volume divided by peak flow rate. Okay, so hourly volume means you take the total of the whole hour. Okay, for peak flow rate, so here you have the flow, right? You have the flow here, and then you have to convert it to flow rate. Okay, clear? So I have 4 values now. I'll pick which one? The peak, the highest. Clear? Clear? Okay. Now here every value was how many minutes? 15 minutes. To convert it to 1 hour? Times 4. Okay. But the actual equation is this one. This is the actual equation. Okay. So peak flow rate and flow maybe for 15 minutes, then you can do this. You see, when I say they multiply by 4, they have written 15 here. Okay, but what if the flow is for 10 minutes? Then multiply by how much? 6. Clear? Huh? 10? 10 minutes multiply by 6. Clear? Okay. Got it? The main thing is you should have flow rate here. Okay, and how to get the flow rate depends upon for how many minutes you have taken the flow. Okay, normally it is 15, so normally it is multiplied by 4. Okay, so if I do it for the previous example, okay, the total was 4200 divided by, it was 15 minutes, so I can do this, and the peak flow was 1200. So this is how we got 187. Okay, clear? Now the range of peak hour factor is from 1 to 0.25. Okay, how do I get 1? If you look at the equation, if the numerator and denominator are same, you get 1, right? So that means volume becomes equals to flow rate. Okay, volume and flow rate are equal, that means all 15 minutes have the same value. So when you multiply by 4 or take the total, they are giving you the same value, right? Okay, so 1 means traffic is equal, all 15 minutes or all flows are equal. Okay, 0.25, how do I get 0.25? You see 0.25 means what? 1 upon 4, right? 0.25 is 1 upon 4. So that means volume equals to what? Only 15 minutes flow. Only flow. Okay, so then I got 0.25. That means what? Volume is for the whole hour, right? In the whole hour, I got the value in how many minutes? Only 15 minutes. The remaining 45 minutes, nothing. Okay, so 0.25 means it is going from very high to very low. Huh? Okay, sorry for giving this example, sorry in advance. Okay, it's like some of you guys. I got D last time, I'll get an A. Your peak hour factor, you are hoping for this peak hour factor. If you had D and you are hoping for D again, well done, then you are here. Okay, sorry in advance. Okay, when do we have this equal traffic? In urban areas, because I told you in urban areas the total traffic is higher, so people distribute equally, so you will get a peak hour factor which is very high, close to 1, and in rural areas it's lower. Got it? Clear? Okay. Okay, we stop here.